So, hexadecimal. This is a fairly niche way of counting that's used in computer science. It's used for colour codes in digital graphics, so Photoshop for example, and not very much else really. I have come across the odd way of using it, but it's pretty niche. It can be quite tricky to get your head around. It's not that difficult, I promise you, but it can be a little bit tricky to start with. Okay. So hexadecimal uses base 16. This is using numbers from 0 to 15, that's 16 numbers in total. Remember, you've always got to include the 0. So it's a bit like decimal. Decimal numbers go from 0 to 9, that's 10 numbers in total, or binary, 0 to 1, that's 2 numbers. So when we count with base 10, with decimal numbers, we go 0, 1, 2, so on, then we get 8, 9, and then we've got to use an extra column. So we've got to use the tens column and the units column, and we go 10, 11, and so on. 110, no units. 110, 1 units, and so on. In binary, obviously, we've got our 1s, 2s, 4s, 8s, 16s, and so on as well. Columns for the numbers. In base 16, so in hexadecimal, we go 0, 1, 2, so on, 8, 9, and then what do we do? Because we can't use the number 10 because that's 2 columns worth of numbers. We've got to have a single column. So we use letters to represent numbers instead. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. Now you've got to be a little bit careful here. It can be really tricky when you're doing this. I tend to use my fingers and make sure that I go 9 and then 10 is the A and then B is the 11, C is the 12 and so on. The really important thing to remember is that A is 10 because it's quite possible that you might end up thinking that A is 11, B is 12. I've done that before. It tends to be a fairly common error. Now when we get to F, we need to then use the next column. Remember, F is 15. This is where you just need to think this through, follow it through on screen, and just get your head around it. So when we're counting in decimal, we go 8, 9, then we need to put a 0 in the units column, and we put a 1 in the tens column. Okay, because we got 110 and no units. Next you'd go 1 in the units, 1 in the tens. Now when you're working with hexadecimal, you just go D, E, F in the same sort of way. So D is 13, E is 14, F is 15. What comes next? Well, in decimal you went from 9 to 0, so in hexadecimal you've got to go from F to 0. Okay, then you put a 1 in the next column. So the hexadecimal number 10 must be the number 16 because it's the number after 15. Now that can seem a little bit tricky to start with, but it works. So the next number is going to be the hexadecimal number 11. That's got to be the number 17 because it comes after the number 16. Now you go back to the header columns, okay, and you think about the left hand column as being your 16s and the right hand column as being your 1s. So the number 17 is 1 16 and 1 1. That makes 17. 16 plus 1 equals 17. Okay, now when the numbers get bigger, you've got to start thinking about letters again. So 1 and 9 is 1 16 plus 9 1s, so 16 plus 9 is 25. What comes after 9 in hexadecimal? Well, that's A. That's the letter A that comes after the 9. So in this column we put an A, in that column we stay with the 1, so we've got 1 times 16 plus 10, well that's 26, okay, which is the next number along, and this carries on. So you get 1 and F, that's 1 16 plus F, well F is 15, so 16 plus 15 is 31. Yeah. Now after F you go back to 0. So 0 in the 1s column, and we increase the 16 column by 1, so we get 20. The hexadecimal number 20 is 2 times 16 plus 0, that equals 32. And you carry on doing this all the way up, and gradually you're going to get more and more numbers getting involved. So the number 9F, for example, that's 9 16s plus 1F, well F is 15, so it's 9 times 16 plus 15. Now this is where the maths gets a little bit tricky. Remember, it's a non-calculator paper, which is, you know, a little bit hard, but 9 times 16 is 144. I worked that out by doing 10 times 16 and taking 16 off, by the way. Okay, so 144 plus 15 is 159. The next number, we've got an F in the ones column, that becomes a 0. In the 16s column, we've got a 9, that has to become an A because that's the next hexadecimal number. So we get 10 times 16, it's 160, which is the next number after 9F. Okay, and we can keep on going. So AA, for example, is 10 times 16 plus 10 for the A, okay, which, nice and easily there, 170. So the largest hexadecimal number you can get with 2 digits is FF, because we've maxed out on both columns. This is 15 times 16 plus 15. 15 times 16 is 240, plus 15 gets you to 255. Oh, hang on a minute, that's a bit of a magic number, because an 8-bit binary number, 8 binary ones, is also 255. You already know this. And this is one of the keys about hexadecimal numbers and why we use them in computer science, because 2 hexadecimal digits, FF, gives us all the decimal numbers from 0 to 255. That's a total of 256 different numbers. That's the same as 8-bit binary. And that's why they're useful for us in computer science, okay? Because when we encode things digitally as 8-bit binary, for example, like we do color codes in hex colors in Photoshop, then suddenly it's much easier for human beings to start thinking in binary. And that's where this slide comes in handy. You need to know these 3 things basically. They'll occasionally ask a question that says, hey, why should we use hexadecimal? Okay, and if you know these 3 things, you'll get all the marks possible for that.